Lesson 7, Coordinate Geometry, Parallel and Perpendicular Lines. Theory. Number 1. Given that L1 is a line y equals m1x plus b1, and L2 is a line y equals m2x plus b2, and L1 is parallel to L2, show that m1 equals m2. Now this is a very easy proof. It's pretty well obvious actually. If we draw these lines, and that one's L1 intersecting here at B1, or B1, and that's the equation y equals m1x plus b1. And another line which is parallel to this one, L2, so y equals m2x plus b2, and this is the y-intercept, 0 b2, and this line is parallel to this line. So if these lines are parallel, then the gradients must be the same. These are the gradients, the coefficient in front of the x's are the gradients, therefore m1 must equal m2. Okay, number 2, given that L1 is the line y equals m1x plus b1, and L2 is line y equals m2x plus b2, and L1 is perpendicular to L2, shows that m1 times m2 equals -1. Okay, then we'll draw these lines. So we draw this one like this, make that L1, and that's y equals m1x plus b1, and we'll call this angle here theta. Therefore, m1 equals the tan of theta. Now we'll draw another line, and for convenience we'll draw it through here. There we go. And we'll make that angle here phi. Now that's at right angles. This is a straight line. So we know that theta plus phi must be 90 degrees. Or we can say that the phi equals 90 minus theta. Now m2 is equal to, now this will be minus, going this way, it'll be minus the tan of phi. This is the obtuse angle. So this is minus the tan of 90 minus theta. Now the tan of 90 minus theta is cot theta. And of course cot theta is 1 over tan. So it's minus 1 over tan theta, which of course is m1. Therefore, m1 times m2 equals -1. Now here are some examples. Example 1, find the equation of the line that is parallel to y equals 2x plus 3 and passes the point -1, 2. Now because this one has the same gradient, we'll be able to form y equals 2x plus some constant k. Now we know the point -1, 2 lies on this line, so we can say that 2 equals -1 times 2 is -2 plus k, which implies that k is equal to 4. Therefore the equation of the line is y equals 2x plus 4. Right, example 2. Find the equation of the line that is parallel to 2x minus 3y plus 4 equals 0 and passes through the point 1, 3. You could rearrange this equation and make y the subject and read off the gradient and do as I did for the first one, but the easiest way to do this one is to actually recognize it'll be of this particular form. That it'll be of the form 2x minus 3y plus some constant k equals 0, and simply substitute in the point 1 for x and 3 for y, and that'll give me 2 minus 9 plus k equals 0, and that gives me that k is equal to 7. So the equation in general form is 2x minus 3y plus 7 equals 0. Example 3. Find the equation of a line that is perpendicular to y equals 2/3 x plus 4 and passes through the point minus 1, 5. Now here we know that the rule for the lines to be perpendicular is that where m1 times m2 equals -1, or if we like, m2 equals minus 1 over m1, which is a negative reciprocal. So we take this m1 here and we turn it upside down, we get the new gradient is simply minus 3 over 2. So this will be able to form y equals minus 3 over 2x plus some constant k. And we put the value of these points in, we get 5 for y equals 3 over 2 times -1 plus k. So 5 equals 3 over 2 plus k. And that means that k must equal 7 over 2. So we have it as y equals minus 3 over 2x plus 7 over 2. Now I might put this in general form, it's a bit unpleasant looking. So multiplying this throughout by 2, we get 2y equals minus 3x plus 7. And take this across, we get 3x plus 2y minus 7 is equal to 0. Now there is another way of doing it, and that is to rearrange this and put this in general form and then swap these over and change the sign, but I'd advise against that because it can lead to error. I think this is probably the simplest way of doing it. But by all means, try different approaches. It's important to find your particular favorite technique. Right, okay, this is an algebraic one. We have to find the equation of a line that is perpendicular to y equals px minus ap squared and passes through the point 2ap ap squared. Those people doing coordinate the parabola, this is the equation of a tangent, and this is the point on the parabola. And what we're trying to find out now is the general form of a normal. But we can just not worry about that and just go ahead as normal and work out the equation. Now we know that the gradient of this is p, so m1 equals p, so m2 equals minus 1 on p. So I'm going to write that as y minus y1 equals m outside of x minus x1, that form. So y minus ap squared equals minus 1 on p into x minus 2ap. Right, now I'll multiply this by p, so py minus ap cubed equals minus x plus 2ap. And we'll just change that a little bit, take this across, we get x plus py minus ap cubed equals 2ap. And then I guess we take this across the other side. So it's sort of pseudo general form. And there we have it. We could take out, I guess we could take out the AP, and we'd have x plus py equals AP into, this would be p squared plus 2. That's okay. Leave it like that.